Hello everyone, Shriman is back again in this tutorial. So now today we will talk about some another topics of matrices and product of matrices. So now let's start today's video. Actually, I was unable to deliver some videos in these going 2 days because there was Ramnami before one day, and so I was a little bit busy in that festival, and so I was unable to make videos. So sorry for that delay. Now coming on point. Now today we will talk about some more properties and some more points and concepts about matrices. Okay, so now let's start. So first of all, you have to subscribe this channel for getting videos on data science, mathematics, machine learning, etc. And you have to share the link of this YouTube channel. Okay, so now as you are looking here, there is something on a screen. So this is just the peculiarities of the product of matrices. So these are some properties that we have to talk about. In previous episodes, we have talked about how to find the products of two matrices. So even if the matrices are a square matrix or they are rectangular, so we have looked that how the product of matrices would be obtained and what are the processes and methods. So now today we will look upon these properties. So coming on this point, this says that the product AB may be defined whereas BA may not be defined. Actually, this point says that if there are two given matrices A and B, then this point says that the AB product AB will be may be defined, whereas this is not necessary that BA will also be defined, because actually we know that products of matrices will exist, or they will be defined if the two given matrices are conformable for multiplication, otherwise they are not. So if A and B are conformable for product AB, then the product AB will be defined, and if they are not conformable for product BA, then BA will not be defined. So this product says that AB may be defined. If AB is defined, then this is not necessary that BA will also be defined. It may be or it may be not. So depends upon the conformability of two matrices for their product. Okay. Now coming to the next point, this says that if AB and BA are defined, the matrices AB and BA may not be equal. This says that if A and B are two given matrices, and suppose A and B are conformable for the product AB and also for BA. Okay, so we can say that these matrices AB and BA are may not be equal. This says that AB and BA will not equal if they are conformable for multiplication. They are not equal because AB is just a different matrix and BA is just a different matrix. They are not equivalent, they are not equal. So that is the product of two matrices are not commutative. So in this case we will always remember this term, that the product of two matrices are not commutative. So commutative law doesn't holds for multiplication of matrices. Now coming down, so there is multiplicative identity. So in previous episodes videos we have talked about additive identity, and so this is the multiplicative identity. So in additive identity we have seen that there is a number that will be added to some matrix or some real numbers, and so after addition we will just get that number itself. So similarly, the multiplicative identity is also a term. It is also such a thing that will be multiplied to any given real number, or any, in the case of matrix, it will be multiplied to any matrix, and we should always get what? We should always get that matrix itself or that number itself. So this is the multiplicative identity. So now let's read its definition. This says that if A is a square matrix and I be identity or unit matrix of same order, then Actually, we have not seen. Actually, I have not mentioned about identity or unit matrix, but uh, actually, I know that these things are some basic things, and we all have studied about these small little things in our school classes or in our 11th or 12th classes. So I think these are not so necessary to explain each and everything, because these are some basic words, basic terms. But however, although I should give some quick brief explanation of these terms. So identity or unit matrix is just a type of matrix, okay? And in these matrix, the diagonal elements are equal to 1, okay? So identity or unit matrix are a square matrix, and they are also a diagonal matrix. And in that diagonal matrix, the diagonal elements are non-zero, and so in the case of identity or unit matrix, the diagonal elements are equal to 1, okay? So our identity or unit matrix will be denoted by I, the capital I, okay? And this identity or unit matrix may be will be a square matrix. So even it will be of order 1, I mean 1 cross 1, 2 cross 2, 3 cross 3. So this depends on the number of rows and number of columns, but identity or unit matrix always will be a square matrix, because you look something that in identity or unit matrix, the diagonal elements are equal to 1. All diagonal elements are 1. So, if there are diagonal elements present, so there is definitely there will be a diagonal, a leading diagonal or a principal diagonal of that matrix. So, if a matrix has some diagonal, then we can't say that that matrix is a rectangular matrix. So, we can say that this matrix is surely a square matrix. So identity or unit matrices are a square matrices, and their diagonal elements are equal to 1. So just this is the identity or unit matrix. So now what this point says that if A is a square matrix and I be identity or unit matrix of same order, then what? Then we can look this result, this relation. So the product of A matrix, the product of A matrix, I matrix will be equals to I dot A, and this will be A. So actually this says that here the commutative law holds for these products. In upper case, in above case, A and B are different matrices. They are not identity or unit matrix. So in this case, here commutative law doesn't hold, but here commutative law holds. Okay, and so this will be equal to this, and so we can write these both will be equals to this matrix A itself. Okay, so this is just the a short relation. We can use it in further relations, in further examples or in problems. So now here what about this I? This I is known as multiplicative identity, because I is just a type of matrix that will be multiplied with the given matrix A, and after the multiplication the product will be itself the matrix. Okay, now coming to commutative law for what matrices. So in this case, AB will not equal to BA. So commutative law doesn't hold for multiplication of matrices. Now for associative law. So for associative law, there is A, B, C are three given matrices, and so we can write this. We can just apply brackets, uh, whatever in which way we can we can apply brackets. Okay. Now, coming to distributive law, what about this? If A and B are conformable for product AB, and B and C are conformable for addition, then we can do this. We can write this. So what about this? So the, A, B, and C are three given matrices, and this is B and C are under brackets, and A is just outside the bracket. So now we can use the left distributivity law, and so this will become AB plus minus BC. So we can use this result. Now coming to the next point. So here is some another type of matrix, and that is what you know, that is the idempotent matrix. So what about this idempotent matrix? This says that a matrix A is said to be an idempotent matrix if A square will be A. So what about the A square? So actually this says that if A is a given matrix, and if A square will be equals to the given matrix A itself, then we can say that A is an idempotent matrix. But what about the A square? What is A square? It's not an algebra that A square and B square will be no, it's not algebra. But what about this A square? So actually this A square denotes that the product of matrix, and suppose this is A square, so the square of the A, and A is what about A? A is the given matrix, so we have to just multiply the given matrix with itself. So we have to write A into A will be multiplied with itself. So two equal matrices, sorry, A matrix will be multiplied with itself, and this will create A square. So this A square, so actually this says that if a matrix will be multiplied with itself, and if their product will be equals to this matrix itself, then we can say that this matrix will be idempotent. And now there is some another matrix, so this says that nilpotent matrix. What about this? A square matrix A is called a nilpotent matrix if A to the power m will be 0, that is m is a positive integer. So what about this? Now here are such things. M is known as the index of the nilpotent matrix A if m is the least positive integer. So this says that here in this case we have just squared this matrix. We have just multiplied twice a given matrix, but here in this case we have to multiplied this given matrix A up to m times. Okay, so A will be multiplied with A itself up to m times. Just just m number of A matrices will be multiplied together. And so if this product will be equals to 0, then we can say that this given square matrix will be known as nilpotent matrix. And so what about this m? This m is a positive integer, this is not a negative or 0, just m is a positive integer, and this m is known as the index of the nilpotent matrix A. And if m is the least positive integer, so actually this is a description about m. Now coming to next point, what about on these points, what this says: product of two matrices can be the null matrix while neither of them is a null matrix. This point says that if we actually, what about the null matrix? So actually as I have not explained about identity or unit matrix, so just I have also not explained about null matrix. So what is a null matrix? So just null matrix is just a type of matrix, and in this matrix the all elements of the matrix will be equal to 0. So a matrix having all its component or element equal to 0 is known as a null matrix. And so this point says that when we multiplied any matrix with any null matrix, then the product will be a null matrix. But this point says something different. So what this says? This says that product of two matrices can be the null matrix while neither of them is a null matrix. We have two given different matrices, just A and second one is B, and we can multiply this two matrices A and B, and the product will be AB. Suppose A and B are conformable for multiplication, and we have multiplied and we have obtained the product AB. So there will be one case, there will be possible that AB will be a null matrix while neither A nor B will be null. So even they are not null matrix, they are not zero matrix, they are non-zero matrix, then even their product will be a null matrix. So just this point says. Now coming to the next point, this says that product of any matrix with a null matrix is always a null matrix. So if there is a matrix, A is any given matrix, and O is a zero or null matrix. So when we multiplied these two matrices, then always there is the case that we should get a null matrix or a zero matrix. So it doesn't matter that what is the of which type the given matrix is. This just says that if one of the matrix is 0 or null matrix, then their product will be 0 or null matrix. Now what about this next line? This says that if AB will be O, then it is not necessary that B dot A will be 0. Before some time I was just explaining this concept that AB will not equals to BA. So if AB will not equals to BA, then it is also not necessary that if A dot B will be 0, then B dot A will must be 0. It is not necessary. It may be or maybe not, because AB matrix is different and BA matrix is different. They are not equal. So it will be 0 or it will be not be 0. So just depends on situation or the elements. Now coming to this points, actually these are some relations. So what this is, so A is the given matrix, and so we have to just powering up, so A to the power n plus 1, and so this will be equals to A to the power n dot A. So this A to the power m to the power n, and so A to the power mn. And so these all things just we have studied in our uh, kids days, in our school days. So just try to leave this. Okay, now coming to next notes. So this is the next page, and now what this says that some, yeah, actually this says about some properties about a scalar multiplication. So K and L are scalars and A is the given matrix, so we can just write this in this way. Now coming to this says that if A will be this is the rectangular array will be used for denoting the matrix, and so d1 d2 d3 dn is the these are the elements of a matrix. And so actually let's remember this thing that if we write A will be in this manner, so we have to just remember one thing, that d1 d2 d3 dn are not normal elements of a matrix. These d1 d2 d3 dn are the diagonal elements of matrix. And so if we write A will be this, then we have to just remember that A is not a general matrix, A is just a diagonal matrix. And so here if we write A will be this, then A is a diagonal matrix, and d1 d2 d3 dn is dn are just the diagonal elements. So in this case this says that if A will be a diagonal matrix having elements like as these, then we can say that if we have powering up the matrix A to K, that means A to the power K, so we can obtain such things that the diagonal elements will also be raised to the power K. So d1 to the power K, d2 to the power K, so d3 to the power K, and so dn to the power K. So if we raise its power, this all diagonal elements of this matrix will also raise their powers up to k. Okay, and so what about this case? So k is just a scalar or just a number, so k belongs to n or natural number. K will be a natural number just. Now there is some very special topic and some very popular topic of this matrix. So this is about transpose. So what about transpose? So this is transpose of a matrix. So transpose of a matrix is defined as a matrix which is obtained from that matrix by changing its rows into columns and columns into rows. Transpose of matrix will be of same order. If A be a square matrix, then A T or A dash will be its transpose, defined as these. So what about transpose? So just we have studied about also about transpose, but here in for a brief description I will say some words that suppose that A is a given matrix, okay, and so A has some elements like as A11, A12, A13, okay, A21, A22, A23, A31, A32, A33, okay. So now what happens here? So just we have just three rows and three columns, okay. So for obtaining the transpose of a given matrix, actually what is the transpose? What about transpose? What is transpose of a matrix? So as we have seen in previous episodes, that when we add two matrices we just get a matrix, when we subtract two matrices we just get a matrix again, when we multiply two matrices, then we get a matrix again. So whatever operations we do on matrices, we do on two or three matrices, we just get a new matrix. So in this case we have to just do another operation on matrix, and uh, uh, as the result of that operation we should get another matrix. So this transpose is the result of the operation that we have to do in this case. And what about the operation? What is the operation? So the operation is just interchanging the rows into columns. So what we have to do, that we have to make the first column of the given matrix A to be the first row. The first row will be made to first column, second row will be made to second column, third row will be made to third column. Either we can also say these three things in a different way, that first column will be make first row, second column will be made to second row, third column will be made to third row. So these two things are equal. If we make rows into columns or make columns into rows, both are same thing. They are not different, but they are the same thing. So just we have to do one thing. Either we have to make the rows into columns, or either we have to make the columns into rows. So just they are the same thing. Okay. So look here, this is the given matrix A, and this is the transpose. So a to the power t or a dash will be used. Look here, a to the power t, just read as at. So this is at or a dash. This is a dash, this is a dash. So at or a dash will be used for denoting the transpose of a given matrix A. So this is the A matrix and this is the A transpose. So what we have done here, so look here, 1 2 3, 1 2 3. So this is the first row. So we have to interchange the rows into columns and interchange the columns into rows. So either we have to choose one thing, either we have to interchange the rows into columns, or we have to interchange the columns into rows. Both are the same things, but if we interchange the rows into columns, the columns will be interchanged into rows automatically. So just look here, we have this first row, the second row and the third row. So what we have done, we have just make this first row the first column. So 1 2 3, the first column, 1 2 3. 4 5 6, the second row will be the second column, 4 5 6, and 7 8 9. So this is the third row, will become third column. So just we have to make all the rows into the corresponding columns. So first row, first column, second row, second column, third row, third column. So just these are this is the operation that will be used for interchanging the rows into columns. And so uh, after doing this operation we will just get another matrix, and this matrix is known as the transpose of the given matrix. And so this is denoted as at or a dash. So this is the transpose of a given matrix. Now here is something, transpose of a matrix will be of same order. Suppose that if A is a matrix of order 3, then its transpose will also be the same order. It will also be of the order 3. So the given matrix and the transpose of that given matrix will be of the same order. Now here AT will be AT will be equals to AJI. So what this means that JI, actually we write here AIJ, but here in the case for transpose this will be JI because the columns are interchanged. So now J is the row and I is the column. So I will be this and J will be this. So just this this is the transpose. Now there are some properties about transpose. So what this says that if we do transpose of the transpose of a matrix, I mean we have to double transpose of a given matrix, then this will be just equal to itself, because we have to just interchange the rows and columns, and then again we have to interchange its rows and columns. So double interchanging will be equals to that itself. Now transpose of these two matrices, so A plus B, transpose of this sum A plus B, so this will be equals to A transpose plus B transpose. Then K into A, K is a scalar quantity, and so the product K into A will be transpose, so this will be K into A transpose. So just these are some properties. You have to just remember these properties, and you have to apply these properties for solving the questions. Now here is something. Just read these lines. This says that A and B being conformable for product AB, both A and B will be of same order and K being any scalar. So these 3 points are for these properties. Okay. Now here are some another topics. So this is the symmetric matrix. What about this symmetric matrix? A square matrix is called a symmetric matrix if Aij will be Aji or A transpose will be equals to A itself. So actually there are a lots of types of matrices. So in those types there are some popular types. So just we have seen some popular types, but here this is also a very popular type of matrix, that is the symmetric matrix. And what it says, what its definition about, a square matrix is called a symmetric matrix if the transpose of a given matrix is equal to itself. Just understand this in these words that A is a given matrix, and now we have to find its transpose. So what is the method of finding the transpose? We have to just do an operation. We have to just interchange the rows into columns, and when we interchange the rows into columns, what we get? We get just another matrix, and in this matrix the rows of A will be the first column, the second row will be the second column, third row will be the so actually we have just interchanged the rows into columns. So actually there is the another type of a square matrices, and in these square matrices when we obtain their transpose, their transpose are just similar, just equal to that of the given matrix. So the elements or the rows or the columns doesn't affect after the transformation, after the interchanging of the rows into columns. So just do one thing. Just take a matrix, just take identity matrix or unit matrix of order 3. So wow, how it looks? It looks at 0, sorry, 1 0 0 0 1 0 0 0 1. So when we just find its transpose, the rows will be interchanged to column. But again, what happens here? After finding the transpose, the obtained matrix or the transpose matrix will be same from the given matrix, from the identity matrix. So if the transpose of a given matrix and that matrix are equal, they are similar, then we can say that this given matrix A is known as a symmetric matrix. So just this is the concept of symmetric matrix. And now there is also a skew symmetric. So what about this skew symmetric? This skew symmetric says that when we find the transpose of a given matrix, and so with a minus sign, this transpose will be equals to the this given matrix A, then we will say that this is skew symmetric. In the case of symmetric, this there will be plus sign, but in the case of a skew symmetric there will be minus sign just. Now coming to next point, there are some properties. So what about the properties? This property says that all diagonal elements of a skew symmetric matrix are 0. So this is a property. This says that if there is a skew symmetric matrix, then its all diagonal elements will be equal to 0. So just we have